According to scientists' current estimates, the range of the universe we can observe, its radius, is about 46.5 billion light-years, which means, from Earth's perspective, the limit of what we can observe forms a huge sphere with a radius of 46.5 billion light-years. Within this space, known as the observable universe, contains at least 2 trillion galaxies. Each galaxy contains hundreds of billions of stars. But this is not the whole universe. It is just the end of our vision. The universe beyond 46.5 billion light-years still exists, but the light emitted from there, in the 13.8 billion years since the universe was born, has not had enough time to reach Earth. More importantly, due to the expansion of space itself, those distant galaxies are moving away from us faster than the speed of light. The light they emit may never be able to cross this stretched space-time, reach our telescopes. Then, what is the ultimate boundary of the entire universe? What lies beyond the universe? The first hypothesis, also the most intuitive view, is that the universe is infinite. This model is simple yet grand. The universe has no end. Space is like an endless vast canvas. Extends infinitely in all directions, no matter which direction you go. At whatever speed you travel, you will never reach a so-called endpoint, or a boundary. In this case, the concept of a boundary itself loses meaning. The universe is an infinite stage. The galaxies, nebulae, and all celestial bodies we know are just a small part of this infinite stage. This view suggests the universe we observe appears uniform and isotropic is because, in an infinite space, any point can be considered the center. The second hypothesis is also currently a widely discussed and accepted possibility in modern physics, that the universe is finite in volume but has no boundary. This seemingly contradictory concept comes from Einstein's general relativity, which tells us that matter and energy can curve space-time. To understand this concept, we can use a dimensional analogy. Imagine we are living on the surface of a large balloon. Two-dimensional beings. For us, the surface of the balloon is our entire universe. We can move in any direction, but no matter how long we go, we will never encounter an edge or end. If we keep going in one direction, we will eventually find ourselves circling back to where we started. For this two-dimensional universe, its area is finite, but it has no boundaries. Now let's elevate this concept to our three-dimensional space. Einstein and others proposed that our universe may be a three-dimensional sphere within a four-dimensional space. In this model, the total volume of the universe is finite, but for three-dimensional beings living within it, we cannot perceive that extra dimension. We'll never reach its boundary. If we drive a spaceship, fly straight ahead continuously, we will eventually circle the entire universe, return from the other side of our starting point. Research from the cosmic microwave background radiation shows our universe is extremely close to flat, but even a flat universe may still be closed in terms of topology. The last hypothesis may be the boldest, the most mind-bending one. He believes our universe is not unique. He is just one of countless universes, known as the multiverse. The concept of the multiverse or the megaverse mainly comes from the theory of cosmic inflation. He suggests that in the very early stage after the Big Bang, the universe underwent an extremely intense, exponential acceleration expansion. In this model, called eternal inflation, the process of inflation does not end everywhere at the same time. Some regions in space may stop inflating, forming a universe like ours, while the vast space around them continues to expand at an incredible speed. In this process, those regions that stop inflating are like bubbles, constantly forming in boiling water. Each bubble is a separate universe. with its own set of physical constants and laws. Our universe is one of the countless bubble universes in this vast superspace.